Yay.
Well, hey everyone. Thank you so much for joining us today. What we're going to do, I'm Rachel and Gaurav.
Hi. Hi, everyone.
We'll do intros in a second. What we're going to do today is we're going to talk about system design for product managers and how AI changes everything. Because the fact that it makes it easier to ship things doesn't mean we need to know less, unfortunately or fortunately. So what are we going to do today? We're going to do some intros and an icebreaker, or an icebreaker and then intros, why it matters, what it means for product managers, a demo, an example, and some interview prep and resources. At the end, there's going to be a feedback form that we would love if you spent 2 minutes answering, and then we'll do about 15 minutes of Q&A. So let's get started. So our today's icebreaker is going to be your name, your role, one sentence of why you're here, and do you prefer ChatGPT or Claude?
Rachel, are you asking me or is it the
This
survey?
is, this is for everybody in the chat to say what they prefer.
Hmm.
Okay, and also your name and your role. I recently fell in love with well, I shouldn't say fell in love with that, but I really like Claude now.
I haven't moved to Claude for some reason. It's still being ChatGPT. I think I'm just too accustomed to this. But
You're
should
also
be.
using Codex, right?
Yes. Codex, which is AI.
Interesting. Cloud for research. I,
I think Claude is winning the
yep.
survey.
Awesome. Okay. Well, it's great that give maybe a few more folks. Anybody preferring Gemini to these two? Okay, let's keep going. So, Gaurav, do you want to introduce yourself?
Yes. Hi, everyone. I am God of Sen. I well I'm a teacher. Yes, I think that's how I define myself. I teach system design, AI. Before that, there was a time when I used to talk about computer programming, computer algorithms. So it's been nearly a decade since I started my YouTube channel, and I have spoken at universities about distributed systems, about AI agents. Most recently, it was IIT Kharagpur. Yeah, and I have a YouTube channel which describes the things that I like to study in more detail. So maybe at the end I can share that with you. But I'm very happy to see you all. Hello.
Thank you, Gaurav. And to everybody who hasn't seen Gaurav's YouTube channel, it has about 800,000 subscribers. So a lot of people find his content useful. And that's actually how I found Gaurav as well. Okay, so hi everyone. I am Rachel Winsberg, and I am a executive coach or a product manager turned executive coach. I have about 17 years of industry experience as a principal product manager, most recently at Amazon, but also Meta, Datadog, and for some reason I wrote Meta twice. My career focused a lot on personalization problems and applying reinforcement learning, which is the backbone of AI, to improve recommendations and personalization, including overhauling Reels content recommendation system in a way that translates to long-term user value. And so, what do I love to do as a coach? I love helping people cut through noise. I like helping people grow faster, find clarity, and build highly performing teams. So, kicking us off, why is system design important for product managers? And from my point of view, even if we're not building it, and with the world of AI, we are going to be expected to build it to an extent, we need to understand it. So we want to be able to speak the language, and that means, you don't need to code, but you need to understand how the systems and the trade-offs that you make impact your engineering counterparts and your clients, and you don't want to turn into a blocker, right? You want to make smarter trade-offs. Whenever you make a decision, it seems easy to make that decision, but it has a technical cost. Any of you who have changed requirements on engineers, you know that that's one of the least favorite things. And the reason for that, every time they plan for something and you make a change, it costs them something. So you want to be able to weigh different aspects like speed, reliability, scale. And when you're thinking about AI, it's really what level of autonomy you want it to have and what systems can it access. And we'll talk about that. You want to scope more accurately. You don't want to underestimate complexity, and you want to make sure that you're setting the right guardrails. You don't want to make stupid mistakes because you didn't peek under the hood. You want to earn engineering trust, even if the bar for shipping is lower and coding is becoming more and more accessible. You want to make sure that you can ask informed questions and that you're not just handing down requirements, right? Your relationship with your engineering counterparts are a collaboration where you're focusing on the what and the why, and your engineers counterparts focus on the how and also on the what in many organizations. And then anticipating failure mode, in my opinion, going from good to great as a product manager, as an engineer, is anticipating what breaks and planning ahead, not just what works. This doesn't mean that you need to be an analysis paralysis, but I hope we give you some tools to understand how to make some of these trade-offs. So if we think agentic AI is just a chatbot that completes tasks, we better think again. Gaurav, what is it all about?
But lots of things. But yeah, it's not just a chat app. Also, I think sometimes there's this mistake that people make that, oh, an agentic AI is basically the large language model. So it's slightly different, and hopefully through the course of this session, we'll be able to explain that in more detail. Yes. But Rachel, you have a really amazing, interesting slide with 4 columns. So
yes.
Let's go through it. Yes.
So what does it do? It's beyond the chatbots, right? It takes actions. Beyond thinking and talking, you have real world consequences, right? You can have an AI bot that then decides which task you want to complete, how to respond to an email of a client, how to create a payment based on a feature if somebody decides to upgrade. It optimizes for different rewards. So when you're thinking about agentic AI and the core of AI systems, and I mentioned beforehand reinforcement learning being one of them, each action that you take has a cost and an expected reward. And so what the AI aims to do is it aims to maximize specific outcomes, and the agent it deploys aim to reach the best outcomes with the smallest cost. And then you want to connect to live systems, right? AI reads and writes to real data. It has access to databases. When you're giving it access on behalf of your users, you're also giving it access to potentially private information. So you want to make sure that you're protecting that. And AI also has memory. It has the short-term context of what's going on right now and the longer-term memory that it can borrow from as well. So it's really important to understand that an AI agent, it acts, it learns, and it adapts in real time. Gaurav, do you have anything to add here?
I think it covers the most important parts
Okay.
Of any agentic system. Yeah.
Awesome. So let's talk about, trade-offs, architecture, and interview preparation. So Gaurav, why don't you walk us through a high level, the agent architecture?
Yes, thanks, Rachel. So as you can see in this diagram, at a high level, an agent is an autonomous system. The reason we call it autonomous is it can react to events, but it may also have its own goal, which is, for example, let's say there's a agent which wants to give you the best recommendations for news. So it's running constantly, and it can react to events of new message coming or something coming up on your feed, but usually it's going out there and searching for things. This could be news sources, RSS feeds, and so on. So the agent's goal, this is important, the first thing you want in an agent is you want a goal. So the goal could be that I want to give the creator or the user the most useful news articles. And the way I'm going to define it now is by the number of likes or the amount of time that the user read those articles. So that's the first component you see over there, the agent on the upper left. It doesn't have a brain. It's actually not intelligent. It has a goal, but the strange thing is it has a, let's say, purpose or a goal, but it doesn't have a way in which to think. So what it does is it takes help of a large language model. So the brain is the large language model. It says that this is what I want to do. This is what just happened. This is a new development. These are the things that I have. And all of the decisions are being made by the large language model. Okay. But the large language model can't take action. It can only talk. It can't do anything. So the agent takes actions. So you also can see there's a database. The database is basically all of the memory of the agent. So previous actions that it took, maybe some things which it finds contextually relevant to any job. In our case, if we are taking news feeds and trying to get the best news, then this could be the news from previous days. It could be the scores of different news outlets. It could be something else. Okay. So relevant contextual memory can be stored long term in a database. And finally, you may not be connecting to a database also. You might be connecting to external tools, external servers. So this could be MCP servers. It could be tools that you have trained the large language model on, and so on. So at a high level, what just happened is we discussed that if there is an agent, it requires control. All of the control is in the agent. It has a goal, it has a purpose. So you encode all of the control in the agent. You also have some sort of memory because previous actions can be punished or rewarded. So that's the second part. The third part is the brain, the thinking piece. That is a large language model. This is where all of the AI is coming from, intelligence. And the fourth part is a way in which you can make changes in the real world. So you can use tools, you can use external servers to make a booking or to actually go and make a like on a post, something which allows the agent to take actions. So these are the four most important parts of any agent. Do you think, Rachel, that we should take a question at this point, or should we?
Yeah, let's take a question. Do people want to ask questions in the chat?
Yes. Maybe you can ask a question on chat, or if you would like to raise your hand, then we can allow one question. Okay.
Okay. If no
Right.
questions and nobody raises hands, awesome.
This is going really well. I think this is super easy.
Well,
super...
sometimes people need to warm up to asking a question.
I see that there is one
question.
Oh,
here, there is somebody asking, how is it different than from RPA? So let's disambiguate acronyms first.
Yes, I have to actually check what is RPA. I know RPC, but I have to check what is RPA.
Well, now I'm checking. So I think RCA is root cause analysis.
Yes, and RPA is robotic process automation. Okay, it's a software technology.
Oh, RPA, not RCA. Okay.
Yes, this is, well, I don't really know. I'm sorry because I don't know about the acronym and I don't want to answer something which will be incorrect. We can have a look at this maybe later. I'll just take another question.
Where would the orchestrator go?
Oh yes, the orchestrator one is an interesting question. Where would an orchestrator go? So the orchestrator is going to be part of the agent component that we have just drawn here. You might have an agent which realizes that it can't perform this action. So then it creates a sub agent which does an action. So let's say there's a complex thing that you want to do. This could be let's say planning an itinerary. So an agent, the thing that you see in the center there, it decides that this is pretty complex. It's a multi-step thing that I need to do. You'll see that this is also the philosophy of LangGraph, or I think it's LangChain. So you get an agent. It decides that for me to plan the itinerary, I need to do 4 things. One is I need to look at all nearby hotels. Two, I need to find the best prices. Three, I need to email these hotels. And four, I actually need to make a booking. So it's a really complex process. And it might spin up different agents to do each of those processes. Every process or every subtask can also spin up more agents. Uh, but I think the philosophy of the current frameworks is to just spin up one agent. So there's the planner and there's agents which take actions. So at most you'll have four agents, but the first agent can spin up a new agent if it fails. So it keeps trying. And then once it succeeds, the second one comes up, it tries. If it fails, it can spin up a new agent and kill itself. And so this is orchestration, where you have multiple agents trying to do one job because it's really complex. And a lot of recent stuff has come up, skills.md, which basically helps agents choose the right skill. But we are going a little ahead of ourselves. Let's come back to the basic architecture. Let's say there's Rachel, and Rachel wants the agent to make a hotel booking, right? So she just says that I am going to India, I'm going to Hyderabad, and what I need you to do is book a hotel for me. Now, the agent is going to firstly try to see if it can retrieve any context. You see the number one there, if it can retrieve any context which is specific to Rachel. So that could be user data, user specific data. It's then going to augment her initial query of book a hotel in Hyderabad with her previous history. This could be chat history, it could be user history, maybe previous actions she's taken. This is called context. This entire thing of setting up the context right is context engineering. Now you take this augmented query, the original query added, you'll add the retrieved context, and you then send it to the large language model. The large language model gives you a response and gives you a set of actions that you should take. Okay. The agent can now go and take those actions. It can connect to the internet. You can see that in the bottom right. It can connect to the internet, maybe booking.com, and actually make the booking. The agent can also do something else. If it's a complex action, the large language model could say, first figure out what hotels are available, and then I'll tell you which hotels to actually book or which hotel to actually book. So this could be a multi-step process also. And yes, so agents can retrieve data, company-specific data, user-specific data. They can augment their original query with this and then generate a improved response from the large language model. This step that you see, this is basically RAG. And
RAG
connecting to external systems is, yeah.
RAG is retrieval augmented generation, right? So for the
Yes.
step of retrieval, you can augment it with data. You can also limit the data sources that it uses for your response to limit hallucinations.
Yes, that is absolutely right. So you can use company-specific data to derive facts. Company data is also helping it ground itself to truths. Maybe a simpler example here, I took a really complex example, but a simple example of this would be Amazon, a user in Amazon talks to the customer support agent, asks for what's my order status. Now, if the customer support agent does not go to its own database, the Postgres or MySQL database, and retrieves the order information, directly sending this query to a large language model makes no sense. The large language model doesn't know what's the status of the order. So the agent first needs to go to its own database, retrieve order information as a JSON, augment the original query of the user, where is my order, with the order information, send it to the large language model. The large language model takes the entire contextual, takes all the context and takes the query and then creates a response. Now the agent can give that back as a response to the user directly, or it can take further actions and then give the response. So this is how you can create a simple customer support agent also.
Okay.
Right.
So I think now we have a good set. In the interest of time, let's keep going, and there will be more time to ask questions as well. So hopefully this is clear,
Sure.
but there will be more time to ask questions as well. Awesome.
Right.
So with agentic AI, Gaurav, continue the some of the
Yes.
points here.
So with agentic AI, things with AI are, have the same problems. One is mistakes are expensive because AI is rather like a black box. It generates a lot of code. Review is more expensive than ever. So if you make mistakes in the design or the prompt phase, they become quite expensive to debug later. So, and trust in the product right now, trust in AI is really, really low because it can hallucinate. It's a part of the generative architecture itself. You can't really help it much. But what people are trying to do are create engineering guardrails so that agents and RAG systems can be trusted more. So this is something that's happening, and fixing bad design is nearly impossible. This is something which is true in general. If you do things right in the start, it's easier to complete that task. It's the same with AI. If you give it the right prompts, if you give it good design, it's going to do well. Otherwise, it's going to create something. You're likely to push it to production just to check it out, and then it's going to be expensive.
Yeah, and it's important to state, when you're thinking about the future of technology and people who are using AI like agentic AI or systems like Cloud Code or Codex, what you can see is writing the code isn't a barrier anymore. So when you're starting to plan out a project with your AI coding buddy of choice, you're essentially doing a lot of system design, right? You're planning a project, you're creating a plan, and you're thinking about the architecture. What is the input, what is the output, and what needs to happen in between? And so the future is a lot more of understanding how the systems interact and thinking about those trade-offs so that you can guide your AI agent, friend, coding buddy to fill in the blanks in an efficient way.
Yes, I'm going through this right now. There's a contest which I was writing code for, and the AI supposedly has access to everything in the world. But the problem is, although it knows our design patterns, it doesn't know which one to apply. Although it knows about writing game playing AI, but it doesn't know which one to apply. So this is something which I think all of us are suffering from at this point in time. Yeah.
Okay, I'm going to continue.
Yes.
So even with AI, you're building a house of cards, right? We're talking about the concept of the foundation. So talk about this, Gaurav.
Oh, so if you know about the waterfall model, guys, or folks, if you know about the waterfall model, you will be familiar with this concept that the requirements need to be crystal clear for the design to be really good, because the design is mapping to the requirements, and the code is almost a function of the design. So once you have your original system broken into microservices or broken into classes and objects, after that, when you start writing code, the code is rather simple, but it is tedious. It used to be tedious. And then you have testing, which is just making sure that you're actually able to meet the original requirements of the system, and that things are not too slow or not too expensive. And finally, you have deployment. But this pyramid really shows that if you get the requirements wrong, everything will collapse. Okay, because deployment is at the last step. Trying to fix things during deployment is expensive. You lose user trust. It's expensive because you have to figure everything out from the start, and it's really hard to dig deep enough to go back to the requirements. Once things are deployed, you're almost always just dealing with code. Design is rare. It can be done. You have major refactorings, but going back to requirements is not something that you're accustomed to do as an engineer. So the more um, time you take on requirements, the more sense it makes in general. And it's
And
actually very true for AI also. Yeah.
it's very true for AI also because it takes so quickly to build, then you're very tempted to launch quickly. And there's a lot more pressure on launching. But from the user's point of view, it's very painful to have a system break your trust. And it's really hard to regain trust while it's broken. So really thinking about the requirements, and now a lot of the boundaries are even more important. when you're thinking about some of the decisions that AI can take, it's not as deterministic as a heuristic. What do I mean? Heuristics are facts, right? If, else, then. Very simple. But if you have optimization functions and you have probabilities, debugging becomes a bit harder as well because you need to find the exact same scenario in order to retrace what caused the error to happen.
Yes.
Okay.
Yes, absolutely.
So I want to switch gears a bit and talk about what are the trade-offs that product managers weigh in on. And this is, or get evaluated on in interviews, right? So data flows in, right? You have an input and you have an output. What happens in between? The goal here isn't for you to say exactly what system, or now you're using a Postgres database or MongoDB or MySQL. It doesn't matter. It's more about what are the boxes that you need, what are the tasks that need to run, what is the data inputs, outputs. These are the key things, right? And then when you're thinking about shipping and shipping fast, there's also how do you ship fast without having to constantly correct, right? So it's okay when you're building an MVP to have some throwaway code and it will save you time. But sometimes decisions are critical in terms of tech debt costs, especially if you're building a system that will later serve millions of users, right? You want to have a simple architecture initially, but then you might want to think about how do you scale it? How do you go from, 10 people to 1,000 people to a million? Maybe you're starting in one geographic area and then another geographic area. Or if you're thinking about LLMs, you might start in English, which is the best language of performance for LLMs, but then expand to other languages, which have less coverage and therefore LLMs are less accurate for. You want to think about your user experience and your engineering feasibility. And you really want to think about autonomy versus control. What is the levels of autonomy? What is at stake? When I was at larger companies, we would call this also, what is the headline risk that you're trying to avoid? What would you not want your AI system to be known for if you're reading the New York Times, right? And then you want to think about real time versus acceptable lags, right? So for example, if you're going to have a dashboard, if it updates in real time, you need to be pinging your memory server all the time. On the other hand, if you can do batch processes, it creates less stress on your servers and it's more predictable. How is this different for engineers, Gaurav?
Well, it's similar in some ways, but it's a little different also. Um, when it comes to interviews, especially, engineers are expected to know some terms, some technical terms. For example, when we say that we are going to use a caching solution, we might ask, is it a LRU cache or is it a segmented LRU cache? What kind of algorithm are you using inside the cache? If you say there's a load balancer, what kind of algorithm are you using in the load balancer? Are you using round robin, weighted round robin? This could be a question. And so one common theme in these questions is there's an expectation that the engineer knows beforehand what these terms mean. So someone just asked about RPA. I don't know about RPA. That if I'm applying for a role where there's robotic process automation and I don't know about RPA, that could be a problem because the expectation is that the engineers are going to communicate with each other and basic jargon is known beforehand. The second thing is technical trade-offs. If you have let's say a system, it could be Amazon S3. So here you might say that I'm going to use Amazon S3 for storing files or storing objects. And then the interviewer could dig deeper and say that, well, we don't care about fetching these objects. These are mostly for auditing purposes. And so then you're expected to know some solutions in that area which are going to reduce cost further, maybe increase latency, but that's fine. So the technical trade-off here is cost versus latency. With Amazon, maybe Glacier, you're able to store files, original video files in cold storage. And so that can help. Consistency versus availability, something I think a lot of us have heard about the CAP theorem. So yeah, that's popular. Thirdly, there are real world solutions that you're expected to know. If you say, I'm going to use a NoSQL database, an example of a NoSQL database is expected. So you can say, I am going to use Cassandra, or I'm going to use something else, a caching solution, memcached, messaging queue, Kafka, event bus, Kafka, database, Kafka, everything Kafka. But it's like the hash map of distributed systems. But yeah, real world solutions, some examples are expected. And in general, I think even the fourth point is pretty much the same thing. It's about the common patterns that are used in these systems. Because coming up with things in an interview is very hard. Coming up with things in the real world is really hard. You want to use tried and tested patterns which have worked for other systems. So in system design, you have the idea of microservices that can be used. You want to maybe think about using a message queue. That's a system design pattern, the event bus, CQRS, and so on. So all four of these points are basically highlighting that for engineers, you need to come up with a solution, but also focus a little more on the technical side of things and think about examples or trade-offs. Yeah.
Okay,
Okay.
so now we're going to do a live demo, and I actually saw a lot of people in the chat asking about something very similar. And I have to say, when I pitched this idea to Gaurav, he told me, well, I already built this. So I'm excited.
Yes.
Go
Yes,
ahead.
this should be fun. I have
And
tried it in
then
another. Yes.
go for it.
Okay. Okay. So the idea is that we want to create an agent which is going to look at our emails on a daily basis, and it's going to run a summary every morning. So the summary is going to be P0 tasks which must be done. You should do it today, and you can have it in a particular order. You can prioritize that. Then comes P1 tasks, which are good to do, are important. You need to do this eventually, but you can add this to a to-do list. And then the third thing you have is things which you can ignore, but we won't print that out. And another thing that you can add here is notifications. So stuff you should know about. It's not a task. It's not something to be done, but it's just something that you should know about. An example, I mean, you can think about the emails that you get every day, but if there's any information which you need to look into, that will be in section 3. Things that you should do, section 2. Things that you must do, you should start right now, are in section 1. So yes, this is the agent. And if this works, it will be something that I think all of you can apply immediately. Yes. That'd be
And if
fun.
I'm not mistaken, we're also going to send instructions on how to try it out yourself.
Yes. Yes.
Awesome. Let's talk about the system design of this agent, the architecture.
Yes. So at a high level, you see that big encapsulating box, which is the email task agent. Someone mentioned about orchestration. This is happening internally in the email task agent. The email task agent has one component of it, which is the Gmail fetcher. If you have worked with microservices or heard of microservices, you can think of each sub-agent being like a microservice for the larger system. Okay, there's Gmail fetcher is something which fetches emails from Gmail. There's the extraction agent, which takes these emails and converts them into easily readable form. Just like HTML, once you have the page, you need to extract information from that page. From Gmail also, you might need to extract useful information. Then you have a prioritization agent, which decides on what needs to be done now and what can be left for later. Then you have your calendar, which can be synced with this. So if there's an event coming up, you can sync your Google Calendar automatically with the agent. Finally, you have the task store, which is storing all of the tasks for the extraction agent. Okay, so we'll look into this a little more later. But at the end of it, the bottom box that you see is the output. You have a priority matrix. You saw the screenshot of that earlier. Priority matrix is a complex way to say that it's just going to output things that you must do, things that you can do later, and notifications. It can also create a daily brief. Yeah, this thing is the priority matrix. Sure. Uh, you can also plug this with a dashboard. Uh, Disclaimer: a lot of the stuff that we have written here is just the architecture. You'll have to change the agent to actually make this work according to your dashboard to get a JSON export or a Markdown file. But the good part is now agents can also be coded using AI. They can be updated using AI. So these are things that we can actually do later. So the output layer is as generic as possible. If you plug this with any other external system, it should work. Okay. So that's the high level idea of what we want to create today. And yes, the task store, which is SQLite, you could also you can use any database that you like. But the basic idea is once you have fetched data, you want to keep that for later. Why? Because the prioritization agent might have its context window full. So as you fetch more and more emails, you keep storing them through the extraction agent into the task store. And later you pick them up and you give them to the prioritization agent and it can continue running. Okay. Any questions? Because I think at this
There are a
point...
few questions at the chat. So there was a question about the waterfall model from Saba. They're wondering if, as we move towards AI-assisted code generation with rapid 2-week sprints, how do you prevent architectural drift? I think that's a really interesting question.
Oh, okay. Well, architectural drift, one of the things that these AI agents or the coding assistants need to do is become aware of your original architecture and what are your architectural principles. So if you have an agent which is helping you write code, what you really want to do is give it the right instructions so that it doesn't completely change your architecture. Low-level design changes are difficult to stop. Coding changes are difficult to stop. But at a high level, your agent should not go around creating microservices and then adding APIs to those microservices unless you explicitly want it to do so. Also, when you're coding now, what would be really nice is not to let the agent roam free. Like I need to create this service and just go away. There's no single prompt which is going to get it right. Instead, think of this as an iterative thing. When the agent codes something, tell it what you want done and make it do exactly what you would do as the engineer. An example of this is, first, what you would do is you would write an API documentation for, let's say, a new feature. After that, you would probably write tests. So that could be test-driven development or behavior-driven development. Then you ask the agent to actually write code. And every time it writes code, it's going to verify against the tests. So at a high level, what you want is more than letting the agent just roam free. You want the agent to follow an exact process and be as deterministic as possible.
Okay. And I think this also goes to the point about requirements, right? If you have clear and set requirements, it reduces, and you understand the trade-offs up front, that would be the best defense from architectural drift.
Yes.
Okay. Let's keep going. Let's see. I see a lot of people having different agents could be.
There's one question: why do we have different agents for different objectives and not have one agent do everything in a sequence? Is it memory or latency which is causing this?
It's a little bit.
So that's an interesting question from HM. So the reason we have multiple agents, HM, is because you have different prompts for different situations. An example is, let's say you're looking to send an email. There's a lot of context that you want to add in an email agent, which if you add it to a general agent, which is trying to do everything, it's going to be too long. Okay, the agent is likely to hallucinate or ignore parts of that very important instruction. So you spin up 4 or 5 agents, and then each of them have a particular skill. Okay, each of them know the thing that they're trying to do. Like in Unix, you do one thing and you do it really well. The same philosophy can be extended to agents now. You want an agent doing one thing, doing it really well, coming up with a response, and then that being sent to the orchestrator, who can then process it and send it to the next agent.
And
it's not so much about latency. It actually increases latency, but accuracy improves. It increases memory also. Memory consumption.
And correct me if I'm wrong, Gaurav, but if you're thinking about microservices versus monoliths, it also avoids one task being a bottleneck for others. So, for example, if one task takes too long, you can have another agent spin up and try to complete the same task in a different way, and then avoid having the system blocked. So, I think a lot of it is very similar to the principle of
Yes.
microservices versus monoliths.
Yes, there's this thing that you want to isolate concerns. This
Exactly.
person will be an expert. Absolutely. So you split it
Awesome.
into multiple things. Yeah.
Cool. Let's keep
Good.
going because we have about
Sure.
5 minutes left. Okay. How to prepare for system design interviews. Gaurav.
Yes. Well, one of the things we want to do is build a technical vocabulary. Like we said, caching, what is that? LRU, LFU. But for product managers, the good news is you don't need to build a very strong vocabulary, very strong technical vocabulary. Basic things like what is caching, what is a unique ID, what is a client, what is a server, APIs, they are sufficient for you to start. And you don't need to code, you need to communicate. Being able to talk in the with technical terms is helpful, but not necessary. Secondly, build some theoretical knowledge around trade-offs, around um, standard architectural patterns. We talked about design patterns. So design patterns and trade-offs are very useful. This is what you'll be speaking with the engineers too. So we have some courses at Interview Ready which can help you. There are also free courses on YouTube. I have taken there's a free playlist on YouTube which you can check out. I think it's pretty good. Go for the simple one if you're a PM. Go for the complex one if you're an engineer. We're expecting more depth as engineers. And practice before the interview. Mock interviews are really, really helpful. You can do this with a colleague as long as they're tech lead or senior, or you can try designing your own system. Just draw out the components, think about why do these components exist, what do they do. And yes, you can see the start here link of YouTube. Click on that, or take a screenshot, ask AI to fix this, and then yes, you can actually go there.
We could have put a QR code, but we'll send an email later with all of the resources. Okay.
Awesome.
So, a practical preparation that I like to give my clients is start with watching an example. So, start with watching a system design video. Ideally, it's relevant to your domain. Don't get freaked out over all of the technical terms. Think about the inputs, the outputs, right? The second thing I want you to do is I want you to reflect on your trade-offs. What are some of the trade-offs that you needed to weigh in on or bat heads with your tech lead about, right? Is it freshness? Is it cost? Is it latency? These are very common trade-offs, right? And then once you've had a chance to do that, take a colleague who is ideally a tech lead or an engineer you've worked with and whiteboard. Fill in the blanks between your input and the output, identify different trade-offs, different key components of the systems, and really try and understand what are the key decisions that were made in the system design that were the most important ones. These are the ones that you should be feeling most comfortable to talk about it. And if the feature is already launched, what are some of the decisions that you would have changed in retrospect? So you want to apply that same growth mindset, that same curiosity. A framework that I like to apply when thinking about system design interviews is, sorry, start with the user problem. What is the user problem that you're trying to accomplish? Try to be specific about what they are and what is their pain. Then you want to show your input and the output, right? In our example, the input was the emails and the calendar. The output was a prioritized list of tasks. Then you want to identify constraints. How many users are going to use it? What is the speed? How real time do you want it to be? How reliable? What are the autonomy limits, right? So, for example, in the example that we gave beforehand on the AI agent prioritizing your tasks, you wouldn't want it to delete emails, right? You're just looking for it to summarize. So you want to limit it to autonomy to summary, read and present, not write or override. Then you want to connect the dots, right? What are the APIs you want to have? Where are the servers located? Do you need a cache layer to improve load time on the client side? And the constraints that you have are going to be important in informing your architectural choices. You don't want to have your architectural choices later on define the constraints. So this is the same approach that we mentioned where your requirements are at the foundation. And then you want to surface the trade-offs. If you, and that's really the question of also self-reflection. What would you have done differently if you have more time, more budget, or more data that you can apply? So there are recommended resources here that we'll send. There are a few videos. This is a simple system design playlist that Gaurav recommends starting with. Gaurav also has a course that he's applying. And then as we spoke about practices, you can do mock interviews with peers, online PM community, also with your tech leads or engineering counterparts. And then papers. We had a lot of questions in the survey that I sent before around how to stay in touch with AI. So we're going to talk a bit about that in a second, but I want to call out when you're thinking about like good papers to read, attention is all you need is the foundation. It's the foundational transformer paper that really built the foundations of modern day LLMs by allowing to pay attention to what's most important and really make a step change from millions of parameters in BERT models before the first model that is the GPT model essentially, and take that into billions of features. And you were able to do that because of the transformer architecture. And we have a bit of a tip here of how to read these and how to stay current with AI tech trends, right? So, Gaurav, what are your thoughts here?
Yeah, I think there are quite a few papers which are very interesting. They are a little dry and they have a lot of information packed in them. So reading a paper takes time, but it's still the most efficient way to get to know something very deeply. So maybe if you're starting off, attention is all you need is a great paper. You can also start off with mixture of experts. It's from Geoffrey Hinton. It's a very good paper. I personally found that a great starting point. um, and yes, there are some recent papers which are also very interesting, diffusion models. But the best way to start is to start from something which is independent and easy to go through. I found Geoffrey Hinton's paper really good, mixture of experts, and also image is 16 cross 16 word. This is one of the most exciting papers for me. I can just share the link with you on chat, maybe everyone.
Yep.
And we'll also, of course, share this on email later. I like this paper because it's 2021, so it's in AI age, it's really old, but it's nice.
Well, attention is all you need is pretty old, but I still like it as well.
Yes.
But really, when
Yes.
you're reading a paper, it's sometimes full of technical jargon and it can feel a bit scary. So, what I suggest doing is start with the intro and the conclusion. Does it seem relevant? Then you can use AI to summarize. There was a period of time where ChatGPT blocked you from being able to do that, but now it's no longer blocked. Put the paper inside and get the key points. Then try and see again, is it really relevant? Do you want to dig deeper? But now that you've read the key points, it's easier to go back and read with a bit more of the minutia for deeper understanding. But if you try reading with like one of the best things about AI, in my opinion, is that it makes the barrier of learning lower because you can actually get that summary first in an intuitive way and then go deeper as you need. So definitely use that as a tool. And that's a great way to stay current with different AI models and be more educated about why things are happening and what are the foundations for the breakthroughs that we see. And that also should give you confidence and be better equipped with understanding how should you build these systems. Okay, so we are now going to ask you all, I'm going to put feedback link in the chat. Darn it, it's not working. Give me 1 second. I need to copy my link. There we go. So we're going to open it up for Q&A now. And I really ask that you spend some time to like 2 minutes to give us some feedback, what worked, what didn't work. And feel free to raise hands and ask any questions. I will I'll probably stop screen sharing if some of these questions aren't related to the deck, but let's see. People can either raise hands or put questions in the chat. Lovely's asking, what are my thoughts on writing Substacks from our own understanding of our domain? Do you think it's important? I think it really depends on what you're trying to accomplish. So, and how much time you have, right? Everybody's excited about starting a blog. Everybody's excited about writing something on LinkedIn. If you're passionate about something and you want to write, there's no harm in doing that. There's a lot of noise. So then how do you find signal in the noise becomes more important. But if you have a unique perspective that you want to share, yes. And if you think that it's valuable, then keep doing it and, make sure that you identify the right channels to promote it. Sometimes writing also helps you make order of things, and getting feedback from the community like you can in Substack can help you deepen the thought process. I don't have a personal preference to one or another. I'm also not sure if it fully answered the question, but it just depends on your ultimate goal. I do not think, by the way, that if you're trying to find a job as a product manager, and I'm not saying that's what you're saying, I don't necessarily think that creating more content on LinkedIn or in Substack is a way to differentiate yourself, unless it's very experiential or a very niche perspective, right? But if you're just looking to exchange ideas or anything like that, it's a fairly good way to get feedback from the community, build relationships, and expand ideas. And yeah, I'm kind of repeating myself.
That's a very interesting question from Ella, which is, can you talk about costs and how do you get asked to estimate cost of running this agentic flow? Or how do you optimize for lower costs, less agents, or isolate concerns? Okay. This is a very interesting question, Ella. One of the things that you want to do before even going for costs is, firstly, you want to evaluate any agent. So maybe you want to think about how do you create evals. Once the evals are set, once you know that this is something worth deploying, and once you have the right guardrails, then you want to estimate costs. Here, what you can do is you can either estimate costs with back of the envelope calculations, which are just rough calculations. At a high level, I have these many users. I expect 10% of the users to actually use this system with so and so frequency. So this is something that PMs do, I think, much better than engineers do, because they are able to make better predictions for user behavior. Yeah, so the way in which you estimate or calculate costs is similar, but the best way to check is to actually go on production. If this is a way in which you're going to make a decision that, okay, I need to, should I fine tune a model? Should I create a specific model for this use case, or should I use an existing system? If that is a decision you're making, then with back of the envelope calculations, you can, if it's very obvious, you can take a decision. Otherwise, you have to test it on production and see what the cost is. Okay, really long-winded answer, but I hope it helped. Okay, yes. Questions? Rachel, would you like me to take this question? It's from Rajiv, which is, how does one prepare for... Okay. Okay, so how does one prepare for the ML engineering role, as the expectations are data structures and algorithms, system design, machine learning models, recommendation systems, computer vision? Oh my God, that's a lot of things. Is there a single approach which can help clear the interview? In my limited understanding of the current space, which is constantly evolving, the technical interview space, data structures and algorithms are still essential. System design is still essential. Yes, some people are, or some companies are asking people to use AI to debug a piece of code. So they're given a piece of code which has a bug. It's been planted in the code. And then you're going to ask AI to detect the bug and then resolve the bug, resolve the issue. You can't code yourself. You're going to ask AI, you're going to prompt AI to do work for you. Okay, so this is a new kind of round that is coming, and it's interesting, but I don't think people are expected to know everything about ML models, recommendation systems, computer vision, and so on. If it's an ML engineering role, yeah, then you are expected to know about basic statistics, how do neural networks work, what is backpropagation, activation functions, and various other things. But then you are an ML engineer, they can expect a few things. Company specific things also could be computer vision. Yeah.
And for product managers, there is also a trend of understanding AI in that context, right? So for example, product sense interviews, which are usually how would you design X for Y? Then what they have is they have potentially a vibe coding round where you're using the AI tool of your choice to help you segment, understand which data sources you're looking to validate your hypotheses, and potentially prototype your solution, right? So that's on one hand. And also understanding the limitations of AI and some of the guardrails that you want to put into it, right? And this also applies to analytical thinking, where you're thinking about how to set goals and how to evaluate success and how to set guardrails. Hallucination is a big thing. How do you prevent hallucination? How do you identify it, detect it? Sorry to spoil it, but it's not that easy. And how do you really think about, building efficiently with AI? So this is like some of the things that you would be tested on as a product manager in the context of AI. Any more questions that people have?
Abhiram has an interesting question for you, I think, Rachel, which is we have a lot of resources for interview preparation of system design for regular PMs and engineers. How different is it for technical product managers to approach the system design interview? Is it very different or is it similar?
From my experience in this, it is more of the high level, like how are the box connecting to each other? How are you thinking about the different trade-offs? It's less about, in most cases, it's less, unless you're interviewing for like a very specific, highly technical role, like a platform product manager, then you would need to know the names of the systems that you're connecting to, but understanding, how to get from point A to point B, what are the key blocks, how information is transferred, what are the trade-offs, how do you protect privacy, how do you think about scaling. I'll give you an example. Let's say you're asked how you would design Alexa or Google Echo, like a voice device, right? So what are the big pieces that you have, right? You need to have a system that understands what somebody says, translates it. We're talking about Alexa from Amazon. You need to translate the voice into language, and then you need to identify the product in the store. And if somebody wants to order it or add it to the shopping list, you need to take the action accordingly. So each of these have a component, right? It's either a function or an API call that you're making or a server that you're connecting to, right? You don't necessarily need to give everything a name. You don't necessarily need to say this is a JSON, this is a REST API. So just to put that in context, but it's important that you flow. Or if you then need to augment that, Alexa to connect, for example, for Spotify, what would that API look like? So if you're thinking about that specific API for Spotify, you could say, well, is Spotify the only music streaming service that I'm going to connect to Alexa, or is it going to be many? If it's the only one, then maybe you want to create something very specific to Spotify. But then every time another music streaming server would want to connect, you would need to create a brand new API, or you would need to augment that existing one, right? So this is a trade-off question of like, how do you scale from one to many? You could create a generic API initially, but that might limit somebody with very specific needs from being able to use the API. So maybe you want to create an abstraction layer for them. So these are the types of concepts that you are expected to understand and good things to brainstorm with your engineering managers counterparts. Abiram, I hope this answers your question. Lovely. I see you have your hand up. Let me unmute you. I'm also going to stop recording at this time because we're already at 10. So we'll stick around for a few more questions, but I'm stopping the recording now. Why isn't it stopping it? Oops.